Imagine, for a moment, that you are holding a piece of copper in your hand. It feels cool, solid, and inert. It doesn't seem to be doing anything. But inside that seemingly placid metal, there is a riot, a silent, frenetic, and utterly invisible riot governed by a rule so simple and so powerful that it builds the world. The rule is this: like repels like, unlike attracts. That's it. From that single, elegant, and utterly mysterious principle, you can reconstruct everything you know about electricity and see the universe anew. Let's start with the riot. Inside the copper, as in all things, are atoms. Picture each atom not as a tidy solar system, but as a crowded social hall. At the center is a group of protons, huddled together. Orbiting them, at a distance vast on their own scale, are electrons. The protons have a property we label positive charge. The electrons are negative, and they are governed by that fundamental social rule. Proton and electron attract each other fiercely. But two protons, or two electrons, will repel each other with an equal, opposite vehemence. Now, here is the first great secret. Nobody knows what charge is. We only know what it does. We have given names to its behaviors: positive, negative, attraction, repulsion, but the essential chargeness, the why of it, remains one of nature's most closely guarded secrets. It is simply a rule of existence, an axiom of our reality. Back to our social hall. In some materials, like rubber or glass, every electron is a loyalist, bound tightly to its own atomic group. They are like people glued to their chairs. They can yearn for movement, but they cannot travel. These materials are insulators, prisons for charge. But in copper, the scene is different. The outermost electrons in each atom are free agents. They are not tied to any one atomic group. They drift, aimless and wandering, through the entire metallic landscape. These are the free electrons. Copper is a conductor because it contains a sea of these nomadic, unattached particles. When you wrap copper in rubber, you are creating a channel of wanderers, surrounded on all sides by immobile prisoners. The electricity can flow along the inside, but it cannot escape through the outside. That is the simple, brilliant trick of every wire in your walls. For the riot to become a flow, for electricity to happen, these free electrons need a reason to move collectively. They need a push. Think of a long, level pipe full of water. The water sits, but tilt the pipe, raise one end higher than the other, and the water flows, driven by the difference in height. That difference in pressure is the hydraulic version of voltage. Voltage is electrical tilt. A battery creates voltage by doing something remarkable. It uses chemistry to pump electrons. It forcefully gathers electrons at one terminal, the negative end, creating a crowd, while taking them away from the other terminal, the positive end, creating a scarcity. This creates an imbalance, a pressure, a desperate need to equalize. Connect the two ends with a wire, and you provide a path. The crowded electrons rush toward the scarce space. That collective rush is an electric current. But the flow is not serene. As the electrons drift, they bump and jostle against the fixed atoms of the wire. Each collision is a tiny transfer of energy, making the atoms vibrate faster. What is that faster vibration? Heat. So a wire carrying current gets warm. This is resistance, the atomic friction of the electron sea flowing through the metallic lattice. A thin wire has more resistance than a thick one, just as it's harder to suck a thick milkshake through a thin straw. Now, imagine deliberately using a wire with very high resistance, like the tungsten filament in an old light bulb. When you force current through it, the collisions are so violent that the atoms don't just vibrate, they glow white-hot, throwing off light. A light bulb is a wire that is bad at its job, gloriously. This leads to a profound realization. We think of electricity as something modern, a human invention. It is not. All of chemistry is electricity. When atoms bond to form molecules, it is a delicate dance of electron sharing and exchange, governed entirely by that rule of attraction and repulsion. When wood burns, electrons are finding new, more stable partners. When your nerves fire, it is a wave of electrical imbalance racing along a biological wire. Life is a sustained electrical phenomenon. We are walking, talking patterns of charge, balance, and we call it biology. Now, hold two thoughts in your head. First, this electrical force is unbelievably, mind-crushingly strong. It is roughly 10 quintillion times stronger than gravity. That number is nonsense. It has no meaning to a human mind. Let me translate. If you and the person next to you each had just 1% more electrons than protons in your bodies a tiny 1% imbalance, the repulsive force between you would be enough to lift the entire planet, the entire Earth. Second, you feel none of this, not a whisper. Why? Because in you, in me, in this desk, in the air, the positive and negative charges are balanced with near perfect, exquisite precision. The titanic forces cancel out, leaving only the faintest ghost of a residue. That ghost is gravity, the force that holds you to your chair. The everyday solidity of the world is a perfect, silent standoff between unimaginable powers. This perfect balance explains why the ancients only knew of two electrical curiosities: that rubbed amber, electron in Greek, attracted straw, and that a stone from magnesia attracted iron. They were playing with the fundamental glue of the cosmos and had no idea. The balance was too perfect to see. Now the plot thickens beautifully. Electricity has a secret twin, magnetism. They seem different. One gives you shocks, the other holds fridge notes, but they are two faces of a single coin. When electrons flow through a wire, they create a circular magnetic field around it. Move a compass near a live wire, and the needle will twitch. Coil that wire, and the field strengthens. Wrap it around iron, and you have an electromagnetism you can switch on and off. And the magic works in reverse. Move a magnet near a wire, and you create a flow of electrons in that wire. No battery needed. Motion itself becomes electricity. This is induction. It is the principle behind every generator in the world. At a power plant, falling water, steam, or wind spins a giant magnet inside a colossal coil of wire. That spinning motion is transformed via this intimate link between motion and charge into the electrical current that snakes across continents to your home. The kinetic energy of a distant river becomes the light by which you read. It is a sublime transformation. This union of electricity and magnetism, codified by James Clerk Maxwell in the 1,860 seconds, yielded an even more stunning truth. Maxwell's equations showed that a changing electric field creates a magnetic field, and a changing magnetic field creates an electric field. They can sustain each other, and this self-propagating disturbance can travel through empty space. When Maxwell calculated its speed, the answer was exactly the known speed of light. The conclusion was inescapable. Light itself is an electromagnetic wave. The warmth from a fire, the colors on a screen, the X-ray that reveals a broken bone, the radio signal carrying this sentence, all are the same phenomenon, just oscillating at different rhythms. We live in an electromagnetic ocean, seeing only the narrowest band of its endless waves. Let this truth settle into your bones. You have never touched anything, not once. When your hand rests on a table, the electrons in the outermost atoms of your skin approach the electrons in the table's surface. Both are negatively charged. They repel. The force of that repulsion, acting across a vanishingly small gap of pure emptiness, is what you perceive as solid contact. Matter feels solid not because atoms are hard little balls, but because the electrical force fields around them are immovable objects when met with equal force. You are held aloft by a continuous, flawless electrical argument between the electrons in your feet and the electrons in the floor. Even the awesome power of a nuclear weapon is, at its moment of release, an electrical phenomenon. In a uranium nucleus, 92 protons are crammed together. Their mutual electrical repulsion is colossal, held in check only by the short-range strong nuclear force. When the nucleus is split, that lid is blown off. The resulting fragments, both positively charged, repel each other with the full, pent-up electrical fury that was being restrained. The explosion is ultimately a sudden, catastrophic victory of the electromagnetic force. So, we have learned to describe this force. We can predict it, harness it, and weave it into the fabric of civilization. We can say what it does with phenomenal accuracy. But the deepest question remains unanswered. What is charge? Why does this rule of attraction and repulsion exist? We do not know. We have found a pattern, a beautiful, powerful, all-encompassing pattern, and we have given it a name. And that, perhaps, is the most Feynmanesque insight of all. Physics does not give us ultimate whys, it reveals profound hows. It shows us the patterns in nature's tapestry. Electricity is one of the most fundamental of those patterns. It is the pattern of attraction and repulsion that structures atoms, forges molecules, animates life, carries energy, and binds the very solidity of our world. We have learned to read the pattern, but the reason for its existence remains a glorious mystery. The universe is under no obligation to make sense to us, yet here we are, having deciphered enough of this silent, electrifying riot to illuminate our nights and power our dreams. And the mystery itself is not a closing door, but an invitation, a sign that there is always more to discover.